All right, folks, buckle up, because the AI world just experienced a minor earthquake. We're not talking about incremental upgrades here. This is a potential paradigm shift. Are you ready to ditch the old "more data is always better" mantra? Because this new research says, maybe not. We're diving into how telling an LLM to wait can unlock incredible reasoning power. This isn't just about faster chatbots. It's about fundamentally changing how we build AI. And that, my friends, affects everyone. The headline? Getting the right data and telling it to wait turns an LLM into a reasoning model. Sounds simple, right? Wrong. This research challenges the very foundation of how we train these massive language models. For years, the thinking has been, throw more data at the problem. Petabytes, exabytes, the bigger, the better. But this team found that a smaller, carefully curated dataset can actually outperform those data-guzzling giants, at least for specific reasoning tasks. Think of it like this. Instead of reading every book in the library, you carefully select the right books and actually understand them. That's the power of curated data. Now, the real kicker, budget forcing. This is a clever technique that controls the computational resources an LLM uses at test time. Basically, you're giving the AI a budget, a limited amount of time and processing power to solve a problem. This allows for a trade-off between thoroughness and speed. Simple questions, low budget. Complex reasoning, higher budget. It's like giving your AI a coffee break. But the implications are huge. This means we can potentially run powerful LLMs on resource-constrained devices, like smartphones or even embedded systems. Imagine having a super smart AI assistant right in your pocket, without draining your battery in 5 minutes. Let's break down the direct impact on AI research and development. First, this research completely flips the script on the bigger is better mentality. It proves that data quality trumps quantity, at least for certain tasks. Second, budget forcing gives us a powerful new tool to control computational resources. We can now fine-tune the performance of LLMs based on the specific needs of the application. And finally, the open sourcing of the code and training data is a huge win for the community. This allows other researchers to replicate, validate, and build upon these findings. It's like sharing the secret sauce, accelerating innovation for everyone. But the impact doesn't stop in the lab. This research has huge implications for the entire tech industry and anyone using AI applications. Businesses can potentially slash training costs and boost performance by focusing on data quality. This lowers the barrier to entry for developing specialized AI applications. Think smaller startups can't compete with the AI giants? This levels the playing field. And budget forcing can be integrated into existing LLM-powered applications to provide more flexible and efficient reasoning. Imagine a chatbot that uses a lower budget for simple greetings and a higher budget for complex troubleshooting. That's smart AI in action. And here's a prediction. This research could even influence the development of new AI hardware. If we can build AI models that are more efficient and require less computational power, we can optimize hardware specifically for those tasks. This could drive innovation in the semiconductor industry, leading to smaller, faster, and more energy-efficient AI chips. It's a win-win for performance and sustainability. Now, let's talk about the big picture. The socioeconomic impact of this research is potentially transformative. More efficient and accessible AI reasoning models could lead to wider adoption of AI in education, healthcare, finance, you name it. This could automate certain tasks, improve decision-making, and even create new job opportunities. Yes, create new jobs. Think about the demand for AI data curators, prompt engineers, and AI ethicists. Reduced training costs could make AI more accessible to smaller businesses, fostering innovation and competition across the board. And the focus on data quality and efficient resource utilization could lead to more sustainable AI development practices, reducing the environmental impact of these massive models. We're talking about a greener, more equitable AI future. But wait, there's more. Let's shift gears to the world of autonomous vehicles. Wave, a leading driverless car company, is expanding into the US market. This is a major milestone for the industry and a crucial real-world test of their general-purpose AI approach. Unlike some companies that focus on highly specific environments, Wave is trying to build an AI that can drive anywhere. Think of it as teaching an AI to drive like a human, rather than programming it to follow a specific route. This is a much harder problem, but the potential payoff is huge. Wave already has partnerships with major players like Uber, Asda, and Ocado. This suggests a clear move towards integrating autonomous driving into existing delivery and transportation networks. Imagine ordering groceries online and having them delivered by a driverless car, or hailing a ride from Uber and having an AI take you to your destination. This isn't a distant dream. It's happening right now. And Wave's success, or failure, in the US will significantly influence investor confidence and future funding in the entire autonomous vehicle industry. The stakes are high. The successful deployment of Wave's technology could disrupt traditional transportation models, leading to new ride-sharing and delivery services. Retailers could optimize their supply chains and delivery operations. Insurance companies will need to adapt their policies. But there are also potential downsides. Widespread adoption of autonomous vehicles could lead to job displacement in the transportation sector. We need to prepare for this and ensure a just transition for affected workers. Increased safety and efficiency could reduce traffic congestion and improve air quality in urban areas. But we also need to address ethical concerns regarding decision-making in accident scenarios and data privacy. Autonomous vehicles collect massive amounts of data, and we need to ensure that data is used responsibly. Now, let's pump the brakes for a second and talk about the potential risks. Because with great power comes great responsibility, right? First, the LLM reasoning breakthrough. The article highlights performance on a narrow set of skills. The model's success on math benchmarks might not translate to other reasoning domains. Scaling from limited benchmarks to more complex real-world scenarios could be a huge challenge. Also, while the article emphasizes the efficiency of a small, curated dataset, that dataset's quality is everything. A shift in the type of questions or the introduction of unforeseen edge cases could quickly degrade performance. The model might be brittle if the real world deviates significantly from the training environment. It's like teaching a dog a trick. It might be great at that one trick, but it doesn't mean it's a genius. And what about the wait command? It relies on the model's ability to self-assess its reasoning and identify errors. But this self-assessment process could be unreliable, leading to inconsistent performance. The model might falsely believe it has reached a correct answer or misinterpret when it needs more time. The wait command could also introduce latency issues in real-time applications. Imagine asking your AI assistant a question and it just pauses for an awkwardly long time. Not exactly the seamless experience we're hoping for. The article mentions specific hardware and time investment. This raises questions about the accessibility and scalability of this approach. Not everyone has access to NVIDIA H100 GPUs. Reproducibility is also a key concern, as subtle variations in implementation or hardware could impact results. And finally, the model may be overfitting on the 1,000 high-quality examples, not generalizing well to unseen data. It's like cramming for an exam. You might ace the test, but you haven't actually learned the material. From a business perspective, the article positions the technique as a way to compete with larger models using fewer resources. But the rapid pace of AI development means that larger models could quickly adopt similar techniques or develop even more efficient methods. The limited scope of the model's capabilities might restrict its commercial applications. And the reliance on open source introduces potential risks related to licensing, maintenance, and security vulnerabilities. Overstating the capabilities of the model based on limited benchmark results could damage the reputation of the researchers or companies involved. It's important to be realistic about what this technology can and cannot do. And now for the ethical considerations. The carefully curated dataset could inadvertently introduce biases, even if the intent was to create a diverse and high-quality dataset. These biases could lead to unfair or discriminatory outcomes. And while the wait command might offer some insight into the model's reasoning process, the underlying mechanisms could still be opaque. This lack of explainability could make it difficult to identify and correct errors or biases. And even with a limited scope, the model could be misused for malicious purposes, such as generating misleading information or automating harmful tasks. We need to be vigilant about preventing the misuse of this technology. Switching back to Wave and autonomous vehicles, the technical risks are immense. The article describes a ride in light traffic in London, but Wave's technology will need to handle a wide array of scenarios: heavy traffic, adverse weather conditions, unexpected pedestrian behavior, and road construction. Autonomous vehicles rely on sensors that can be affected by lighting conditions, weather, and obstructions. Autonomous driving software is complex and prone to bugs, and autonomous vehicles are vulnerable to hacking. The cybersecurity risks are very real. From a business perspective, the autonomous driving industry is highly competitive. Wave will need to differentiate itself to succeed. Autonomous vehicles are subject to strict safety regulations, which vary by jurisdiction. Wave will need to navigate these regulations to deploy its technology. and public perception of autonomous vehicles is mixed. Wave will need to build trust in its technology to achieve widespread adoption. People need to feel safe and comfortable sharing the road with driverless cars. And finally, the ethical challenges. Autonomous vehicles must be safe for passengers, pedestrians, and other road users. Accidents involving autonomous vehicles could erode public trust and delay the deployment of the technology. The widespread adoption of autonomous vehicles could lead to job losses for truck drivers, taxi drivers, and other transportation workers. Autonomous vehicles collect vast amounts of data about their surroundings and their passengers. This data could be used to track individuals or to personalize advertising. And autonomous driving systems could be biased against certain groups of people. We need to address these ethical concerns proactively. So, what's the takeaway? The AI revolution is here. We're seeing incredible breakthroughs in LLM reasoning and autonomous driving. But we also need to be aware of the potential risks and challenges. We need to focus on data quality, ethical considerations, and responsible development. The future of AI is not just about building smarter machines. It's about building a better world. And that requires careful planning, open collaboration, and a commitment to ethical principles. What do you think? Is the small data, big brains approach the future of AI? Are you ready to trust a driverless car? Let me know in the comments below. And don't forget to like and subscribe for more in-depth analysis of the latest AI trends. Thanks for watching.